Like he said, my name's Durham. I'm on the source control team at Facebook. And I know it says scaling Git at Facebook, but we don't actually use Git at Facebook. We use Mercurial. And that's the slide he was talking about. That took 2 hours to make that thing fall. And so this talk, it's not going to be about why we use Mercurial. You can find that out online. We did a blog post. And it's not going to be about why we use monorepos. There's many blog posts that cover that. Instead, I want to talk about the specific technical things we've done around scaling our repo and scaling our user experience that I think would be applicable to the Git community and that I kind of hope the Git community adopts so we can kind of move forward together in this version control world. But first, you kind of have to have some context about our repositories. For one, we use monorepos. We've got 2 of them. One is FB source. That's kind of our mobile and our backend and a bunch of other stuff. The other is www, or www. That is our front end of facebook.com, the PHP, the JavaScript, all of that stuff. And that's where the vast majority of all commits go, into one of those 2 repositories. The second thing you need to understand is that we don't use feature branches, really. Locally, people use them, but there's no feature branches on the server that are persisted for any amount of time. Everyone's committing directly to master, and no one stays off master for very long. And I'll talk a little bit about how that works. We also use almost exclusively rebases, no merges. In fact, we have disabled the HG merge command in FB source, so none of our users can run it. If you don't know, HG, that's the symbol for the command line interface for Mercurial. It's 30% shorter than Git, so that's an immediate perf win. But we use exclusively rebases. And kind of a corollary of that is that we do single commits. You don't make a stack of commits and then like merge that in. Instead, you'll have a single commit that is small and incrementally moves the repository forward, that is code reviewed, passes the build, passes the tests, and it results in this history that is very linear, very maintainable, very understandable, very bisectable, and very scalable for an organization of our side. You'll see we tend to assume our developers are online, and some of the scalability things we do are around the online experience, and we take advantage of that. They can work offline, so we don't take that away, but you'll see that we do orient ourselves towards our developers being online. If you're familiar with Mercurial, you know there's bookmarks and there's branches. We use bookmarks. If you don't know what Mercurial is, it's another distributed version control system. If you don't know what these words are, don't worry. Bookmarks are just like Git branches. So anytime I say the word bookmark, just pretend I said branch, and it works just like Git. And lastly, we ship the absolute latest version of Mercurial. Not just like the last release, but we ship today's latest master branch to all of our users, and then we layer some extensions on top to improve scalability and change some of the user experience. And I'll talk about kind of the ways in which we change it. So we are shipping the very latest Mercurial. And hopefully this gives you a bit of context into how we work and kind of sets the context for what you'll see as we talk about some of these problems we have. The first problem is of scale. And there's tons of axes of scale in version control. You can have too many files in history, too many commits per hour. Your files can be too big. And we have to address all of those as part of making our repository scale to our growing company and our needs of the future. And unfortunately, I can't actually tell you how big the repository is, which is a real shame. But what I can tell you is that think of the biggest Git repo you have ever heard of, and we are bigger. This is the biggest distributed version control repository I've ever heard of. And to give you an idea of how fast it's growing, even though it's already big, this is a chart of number of files in the repository over time from 2008 to 2016. I got hired right around that little blip at the bottom, and I was already scared. And now the curve is only going up. And that's the worst part about version control, is you never delete anything, so that it only ever goes up. And we need to scale to meet that growing demand. Now, the other side of the problem area is user experience. We hire hundreds of engineers, and we have to onboard hundreds of engineers, and there's only like a few people on the source control team. So customer support doesn't scale. And the current command line interfaces, they're, I think meh would be a conservative way to describe them. For both Git and Mercurial, they're not great. And what we need is a user experience that is easy to learn, trivial to recover from, and makes power user workflows available to even novice users. And so later, I'm going to talk about kind of the ways in which we've done that, and hopefully Git can take advantage of some of those same things. First off, though, I want to talk about the details of how we scale. Oh, I have a clicker. It doesn't work. That's all right. The first thing I want to talk about is push contention. And I think a previous speaker alluded to this, but basically push contention is when you as a developer, you want to push. So you pull, rebase on top, and attempt to push. And if anyone else has pushed in that interim, you have to try again. And when you have thousands of developers all doing this at once, you end up with these really long queues of people waiting, and it becomes a huge productivity bottleneck. And we can't have our users waiting on source control like this. So the way we've solved this is with the Mercurial extension we call push rebase. And basically, it allows the server to perform a rebase for you in certain conditions. So in this example here, commit X is on the client. We want to push it to the server, but the server has the master C. So when you push it, the server accepts it, rebases it for you, and then sends all of that data back to the client. And now the client receives the updated X, and the push is complete, and the user did not have to have the latest master. And so this allows many people to push at once and avoids the push contention problem that Git and Mercurial currently have. And this has basically solved push contention for us. To show you kind of how much, this is number of commits per hour in some of our biggest repositories. That bottom orange line, that's a Git repo before we merge it all together. And you can see at the beginning of the day, it hits peak maximum throughput, and it stays pegged at the maximum possible commit throughput throughout the whole day until the work ends. The blue line above it, that is FB source. That is when we have merged repositories together, moved to Mercurial, moved to push rebase, and we're handling 4 times as many commits per hour as we previously were. And more importantly, the line doesn't cap out. So we have not hit our maximum possible throughput yet, so we have more room to grow. And so this is really important for us being able to make FB source a viable monorepo and scale to thousands of users. Now, this basically, like I said, solve push contention. It also works with merge commits. So if you come from a pull request type workflow where you have a branch and you do a pull request and a merge comes in, it can rebase the merge commit. So it's not limited to the rebase workflows that we use. It can also work in kind of your standard GitHub your standard GitHub kind of flow. It also has a nice benefit of moving hooks out of the critical path. If you have a slow hook that takes a minute to validate something, talks to an external service, runs something expensive, and you put that on the critical path of pushing, then that's going to be a problem, and people can't push because that's taking up so much time. So with push rebase, this allowed us to move the hook to before the rebase, before the critical path, and we can run it in parallel on everyone's pushes at the same time, and then only afterwards, in the rebase push part, which is the critical section, only that matters. And so hooks no longer affect our total commit throughput. So what is stopping Git from doing the same thing? Not much, actually. I think all Git would need is the ability to return a commit during a push. And if it could do that, this follows very easily from there. And this is kind of a theme of the talk, is that a lot of these things are really within Git's reach and could easily be done with just a little bit of elbow grease. So push rebase allows our users to push as frequently as they want. Now, that introduces a new problem, which is our users are pushing as frequently as they want, which means we have this huge repository. In Git, it's a .git directory. In Mercurial, it's a .hg directory. And we realized it kind of breaks down into 2 parts. One is the commit metadata, and the other is the file content. And if you look at the ratio of these 2 things, commit metadata is this teeny, teeny slice, and file content is everything. And users, they don't need the file content from a month ago, much less a decade ago, yet we download it to every single client, every single time they clone. So to address this kind of problem and to help our scaling issues, we created this thing we call remote file log. And the way it works is basically, this is how Mercurial structures its data. There's a bunch of commits, there's a bunch of manifests. Manifests are kind of like a Git tree. It's a list of files that's in each commit. And then there's all the file content for all the revisions that any file has ever had. So what we did is, instead of just cloning everything like normal, we just don't clone everything. We only download commits and manifest, which is tiny, very similar to what Microsoft described earlier. And then on demand, we grab the exact revisions you need and we put them in a cache. And we can prune that cache if it gets too large, and we can re-download them from the server. And we can start to play around with this. And so this has a lot of benefits. Mainly, it allows us to take our big repo and start treating it like a small repository, especially with like a sparse checkout where you only check out certain files. Now you are checking out certain files and downloading certain files, and the time complexity of all these operations starts to change. And you'll see this theme throughout all the scalability improvements we do, is that the problem is not that Mercurial's in Python and Git's in C. The problem is that time complexities are hard, and we need to make better algorithms. And this is the start of this. It also lets us do this cool thing where we're starting to take advantage of both the advantages of centralized version control and distributed version control. So centralized lets us keep things on the server and fetch them at will. And distributed lets us make offline commits and do peer-to-peer pushes, and all that continues to work. And we're starting to blend them into this hybrid and getting the advantages of both. And I think there's some really interesting workflows that are going to kind of come from this unioning that we're doing. So push rebase lets our users push as frequently as they want. Remote file log lets them push as much as they want. You'd think we'd be done. But now our users want to push as many branches as they want. And when you have a lot of users, it's a lot of branches. We've got release branches. Every week, every product, new release branch. We've got scratch branches. Like every hackathon, every team wants to make a scratch branch. We have a few feature branches. I told you we don't use them much, but there do exist a few. And if you push a lot of these, A, it's a lot of data, but B, certain algorithms don't scale well when you have hundreds of thousands of branches. And some people have talked here about how Git refs work in the same way. And so we don't want to have all of that on the server. To fix this, we created another extension called infinite push. And I really like the name because it sounds really cool. But now, when you push a branch to the server of a certain type, like it may have // in front of it, instead of putting it on the server redirects it to a scalable blob store, which is something where we can put basically infinite amount of data in there. So the file content goes in the blob store, the metadata goes in SQL, which is also rather scalable. And this basically allows us to have an unlimited number of user branches. That by itself, it's kind of cool, but it's somewhat of a parlor trick. Git could do this easily. What I really want to talk about, though, is the ramifications of this technology. This we built. The ramifications we're building. So this is kind of future looking. One of the ramifications of being able to push an unlimited number of commits is, why don't we just push all the commits? If a user types hgcommit, behind the scenes, we will push it for them into this blob store, and now it's on the server and available to everyone. I could literally type hgcommit, copy the hash, message it to my buddy, and he can type hg checkout that hash, and it would just work. No pushing, no pulling. So it's breaking down the barrier between my repository and his repository and the server's repository, and making it so we can all kind of interact and data can flow freely without any effort on the user's part. It lets you do cool things like recover commits trivially. You lose your repository, no big deal, clone a new one, check out your bookmark, you're done. It lets you do things like synchronizing between machines trivially. Work on a bookmark here, switch to that machine, your laptop, your desktop, work on the bookmark there, and it just works. The data flows very easily. It has ramifications on automation. What if every time you made a commit, it went off into the cloud, and the build ran, the test ran, the static analysis ran, and it came back and annotated your IDE with the results? And so now automation can start to play in your client-side developer environment while you're still using distributed version control. It lets services start to participate in this commit cloud. So you could have a code review UI where I, as a reviewer, want to suggest a change. I can type in the change, hit submit, and then it goes into the cloud, and it could show up in your client as a suggested change in your repository as another commit, and you can choose to use that or not. And so this remote file log plus infinite push are kind of introducing new workflows that never existed before. Things where users don't have to care where their data is. They can communicate with their peers very easily, and where they can integrate with all these services, and it just kind of works. And this is kind of where we're going with scalability, is making all of these things seamless. So that's the end of kind of the scalability portion. These are three main things that I think Git could easily adopt and do a very similar concept. I know Microsoft is heading in this direction already, so I'm excited to see that. On the user experience front, I think Git also has a lot of work to do, and we, as a source control team at Facebook, have a lot of work to do. Like I said, we hire hundreds of engineers, and it just doesn't scale for us to support them all manually. So I'm going to talk about a few things we've done in specific about user experience to make it scale better. The first is around log. Log is like the first command you learn after clone, and all it tells you is it actually doesn't tell you very much. It tells you what commit you're on, its message, and if you're lucky and your page is long enough, you can see the commit after it. It doesn't tell you what branch you're on. It doesn't tell you where your other branches are. If you work at a company like Facebook with thousands of engineers committing, you see your commit and then thousands of people you don't care about. And so we found people using log just did not have a good grasp of their repository. So to remedy this, we introduced something called smart log. And this one has a lot of clicks. So I'm going to stand over here. But basically, it's a much more information-dense, more readable user experience to understanding your repository. It shows you things like where your working copy is right now. That's that purple line. It shows you where your other branches are. Here's my branch, and it's over there. It shows you where the remote branches are. So master, it's right there. It does this cool thing where it hides all the commits you don't care about. That little dot, dot, dot in the corner, that's it eliding thousands of commits from users so that you can see the structure of your repository without all the cruft. It shows you things like metadata about the commits. Those D numbers, those are code review identifiers. So now from this diagram, you can even click on them in certain terminals, and it'll take you to the code review. It shows you the difference between your local commits and the server commits. The bright yellow bold, that is a local commit. The kind of darker yellow thin, it's a little subtle, but that's the server's commits. And so in this one UI, you can start to see all these different pieces of information really intuitively. It shows you where commits are that don't have bookmarks or branches. For instance, in Git, if you delete a branch, you have to then understand the ref log, God help you, to recover that commit. Here, it's right there. There's the hash, put a bookmark on it, you're done. You don't even need a bookmark. That's kind of a Mercurial feature, but like this ability to recover easily is what we're going for. And this last bit, this is my favorite bit. This little X with the gray words next to it, that is us starting to show users how their repository has changed over time. In this case, it says pushed as blah. That means that local commit has already been pushed to master, and that's the hash. So I know from seeing this that I need to take that top commit off and rebase it onto master. And so now we're starting to explain how their repository has evolved over time in a very intuitive way. And this UI is the single most important UI at Facebook for source control. It is like, I teach boot campers. Boot campers are new engineers at Facebook. I teach them, and I teach them, here's how you clone, and then here is HG smart log. And now you can go to sleep. Like, we're done. Because this explains their entire repository to them. It explains how it fits together. It explains, like, when they run rebase, they see the before and after, and things start to make sense. I had someone come up to me and say, SmartLog made me understand what it's just a DAG means. So SmartLog is explaining Git to them, and they go back to the Git community smarter for it. And now, I know Git can produce this kind of UI if you know the incantation. But the critical thing here is not that it can be done, it's that it becomes the default view on their source control environment. That is where the power comes from, is making it really intuitive for users to use source control and to understand the concepts without reading a man page. So I think it'd be very easy for Git to do something similar. So that's kind of about understanding the repository. There's also problems with editing repositories. And stacked commit workflows in particular have a lot of trouble. I had a new engineer come to me once and he said, my repo, I need help. I'm like, I got this. Like, I'm paid to fix repositories. And so he runs his smart log, and it's like 45 commits long, and there's branching and merging and forking and things going down. I'm like, how is that even possible? Nothing goes down. And I looked at it, and I was like, you know what? God help you, because I'm out. I can't do this. And so stacked workflows in Git and in normal Mercurial today look a lot like this. You run rebase-i, and first of all, why am I running rebase when I want to edit my stack of commits? Like, as a user experience, that's a little weird. As a developer, I understand, but it's not a great UI. But then let's say I want to edit commit B. I change it to edit, I enter into this very stateful thing where I have to remember to do my work and then continue. It's just not an intuitive flow. And so we've done a lot of things to help the stacked workflow for people. I want to talk about one because it's really freaking cool. It's called HG Absorb. And basically, it allows you to have a stack of commits. You can have some pending changes at the top, and it will detect where each part of your pending changes belongs in the stack, and then automatically perform the amend for you into all the right locations without any conflicts. If there's a chance of conflict, it will leave it pending, but everything else gets amended trivially. So here's an example. I'll illustrate it for you. So this is my before state. I have 3 commits. I introduce a main, I add a print hello, I add a standard library include. And this is my pending change. I add another standard library, I change hello to world, and I replace 0 with success. In Git, if I wanted to perform this amend to all the right places, I'd have to do something like this, where I git commit-p to like pick one chunk. I have to git -p or git commit-p with an edit to split that 2 lines apart. And then after all of that, I have to do a rebase-i, reorder things, change it to fix up, and pray that there's no conflicts along the way. So this is a very understandable thing a user wants to do with a very convoluted way of doing it. And so with absorb, they can literally just type hgabsorb And it just works. In this case, the top line, it figured out that the standard library probably belongs in that top commit. And so that's where it puts it. It figures out that printf hello was in the second commit. So let's put world in that one. And it figures out that the return 0 became return success. So it puts it in the first commit. And so this is the type of UI that we need to be inventing for our users. Ones that match their intent and do it to their best of ability without making the user understand what all they have to do. And it's a little bit magic, but it's magic in a very clean way. And so I think a lot of user experience could benefit from this approach. And that's just the tip of the iceberg. We've introduced a whole bunch of commands that I can't get into, but that help the user experience. hgfold, hgsplit lets you fold and split commits. No more using git rebase, squash, blah. I don't even know how you split a commit in Git. I guess edit and reset or something. But that's hard for a user, and this is trivial and memorable. If you want to edit a commit in the middle of a stack, instead of using git rebase-i, you can just check out the frickin' commit and run amend. And it just works. And once you've messed up the middle of your stack a bit, we have this command called restack that brings it all back together. And so this is about creating UIs that are much more intuitive. And that applies to recovery as well. Santiago earlier, I think that's his name, hopefully, that talked about ways in which we can improve the UI, talked about recovering. So if you want to undo an amend or undo parts of a commit in Mercurial, you just run onAmend and onCommit now. You don't have to understand a ref log. You don't have to get a PhD to understand reset anymore. It just works. And it gives users confidence that they can recover from mistakes. And that's one of the most important things we can do, is provide user experiences that give them confidence in what they're doing. And so there's a whole lot more, and I'd be happy to talk with other people about this, but that's just what I want to highlight here. So the last two things I talked about were user experience. This one here is about kind of organizational experience. Sparse checkouts exist in both Git and Mercurial, and if you Google, how do I use a sparse checkout in Git, this is the first page. And first of all right, you're editing some weird file, and then you run git read tree muhead. I work on source control, and I haven't figured that one out yet. But the worst part of this is more subtle. It's that if you want to use this at an organizational level, you have to have all of your users run this. And then if one guy over here adds a build dependency, all the users have to edit their file again and run git read tree muhead. And that's just not going to scale unless you put a lot of tooling on top of it. So that's the part that prevents us from using this kind of functionality at an organization. So in Mercurial, we invented this concept we're calling sparse profiles, where it is a sparse config that is checked into the repository and versioned, and it changes over time, and the user's working copy updates as they commit. So in this case, if they have the Android profile enabled, if they're on commit A, they have Android Messenger. If they're on commit D, it adds Android Common. If they go back to A, Android Common disappears. And so at Facebook, in FB source, 100% of people are using sparse checkouts and via these sparse profiles, and only 90% of them even realize it. People are adding dependencies, removing dependencies, and the sparse profiles are growing and shrinking, and the vast majority of users, they don't care. So one person's job is to update the dependency, because that's the person adding the dependency. Everyone else, zero effort. So this kind of solved the organizational overhead of using sparse checkouts. And this would be really easy for Git to add. I mean, not really easy, it's a little complex, but totally within reach. That and a little UX, and sparse becomes an actual feature that actual people will use without tooling around it. You may be wondering, how do we prevent it from getting out of sync? Someone adds a dependency, they don't update the profile, that could break it. Our test infrastructure uses these sparse checkouts. So if you add a dependency and you don't tell the sparse profile, the tests fail, and you're made aware, and you can't push it to the server. So this was a kind of the insight we needed to make sparse checkouts work at scale with all of our users. And I think Git could really benefit from this exact same kind of technology. All right, the last things we talked about were kind of user-facing. But there's a whole side of source control that is automation-facing. And they have a lot of demands. They need to be able to list the repositories, tail commits, see contents, run blame, run log. Automation should be able to use source control. And the way we did it before is all of the services that needed to use source control, they cloned the repository, and they had bash scripts or something that ran git log and hglog, and they attempted to parse the results and handle error cases. And every single one of these services did that. And these are not written by source control experts. These are written by engineers who have normal jobs that don't require understanding what git checkout -x means. Is that a thing? I actually don't know. And so this was a huge pain. A, these services are extremely stateful. You can't just like take one down and spin it up somewhere and clone tens of gigs. That's not a short process. And like I said, it has tons of technical debt in all the code where all these people are trying to handle edge cases. So to fix this particular issue, we created a service called SCM Query. And it's a thrift service. If you don't know what thrift is, it's kind of a remote RPC system call across networks, very similar to proto-buffers. But basically, it's a service that sits on our Git and our Mercurial servers, because we do have Git servers, we just don't use them much. And the services that are out there, if they have a question about source control, they just ask the service SCM Query, and it answers in a type-safe, structured way. And so, first of all, this is VCS agnostic. So now our services, they don't care about Git, and they don't care about Mercurial. They just care about answers. And that has helped us with our transition from Git to Mercurial and from Subversion to Mercurial. It means we can start to memcache results. So expensive things like blame, we don't have to do it every time. It means we can redirect certain things to indices. So log on a file. If your repo is long enough, logging on a file takes a long time. So we built an index for that, and now it's instant. It lets you do things like, now all of these services are stateless. We've deleted tens of gigabytes from them, and now they're lightweight, they can spin up quickly, fail over quickly, and the whole world's a little nicer. And my favorite part is that we replaced all that crappy bash code with just type-safe thrift. So all that technical debt just vanished. And we originally did this for just a couple users, a couple services who need it. But it has had a dramatic effect on the entire source control ecosystem at Facebook. Like every service, we're creating new services that we never before even thought could exist because they would have required all this cloning to be done. So I don't know if Git has something equivalent to this, but if it doesn't, you should totally build it. Because like services should be able to use source control, and the command line is not the way to do that. And so this has been really beneficial for kind of scaling services on source control at Facebook. All right, I want to leave you with some final thoughts. On the scale side, I'm really excited to see like Microsoft stepping up and these other companies stepping up and making Git scale. I actually just talked with Saeed, the Microsoft guy who talked to you, in the conference room back there, and we're going to have like coffee next week or something, because that's going to be really cool kind of seeing these two things move together like that. On the user experience side, we as a source control community need to do a better job of building UIs that are accessible, intuitive, and that enable novice users to be power users. Everything I just talked about is how we are trying to do that for our users in Facebook. But if the Git community could do that, and the massive number of Git users could take advantage of that, that has the potential to redefine productivity for an entire generation of users. And so I think that the single most impactful thing Git could be doing right now is producing an intuitive user experience that enables these users to do the cool things that today only power users can do. So I just want to leave you with that. Thank you very much for having me. Thanks for not pulling out your pitchforks. I'm very appreciative. And thank you very much. Five minutes? All right. The clock says I have 5 minutes, so we can actually do questions. And I cannot see anyone, so I'm going to get really close up here. How about there? All of it is open source. Everything we've done is open source. It is not all, so the question, sorry, was why is this not open source? It is open source. Not all of it is in core Mercurial because certain things break backwards compatibility, but it's all there for people to use. In fact, some of this other companies are also using. Why did you not know about this? Do you use Mercurial? Yes? Well, because it's complicated. If people start using this, they break backwards compatibility. It becomes harder for them to get support from upstream, to get support from Stack Overflow. So there's complications there, unfortunately. We're trying to get parts of it into core as well right now, though. In the corner? What happens when push rebase introduces a test failure? Then continuous tests catch it, and we yell at the guy. Even at scale, though, push rebase has had very few situations like that. This is very similar to how Subversion does commits, and tons of companies use Subversion, and it doesn't seem to be a problem. So it just doesn't seem to happen, luckily. Yes? You said the what developers? So do Facebook developers use Git repositories to do feature development? And the answer is generally no. 90% use Mercurial directly. There's some small repos, like we have Oculus. They were an acquisition. They have different needs. They use Git in some cases or other things. But no, the vast, vast majority use Mercurial. Where are we looking? Anyone? Yes. So the fact that we're doing all these merges and stuff on the server, does that not cause problems? So one thing, like I said, is it will not do a textual merge at all. So if someone else has touched the file you touched, it will not perform the rebase for you. Now it's possible that there introduces a build break by two people committing at the same time to different files. Generally, it's not a problem. We don't let you push if you're like 3 days old. We're not going to rebase that for you. So usually you're very close to master already. And so the window for issues like that is very, very slim. And I've not seen a case of it so far. In the back. How do we do code reviews? With the code review website, I guess. I don't understand the question, sorry. So you do your code review before you push to master, and it shows up in the Fabricator web UI, and only once it's accepted do we allow it to go to master. No commits go to master without first being code reviewed and completely signed off on. One more. Okay, last one. Yes, we are exposed to Mercurial bugs because we run the Mercurial nightlies, and that's good for the community. We catch things before anyone else, and we have a lot of automation to kind of catch these things. All right, thank you very much for your time. If you have other questions later,